Hello. Our class will begin, and thank you for joining the live stream. Since today is a typhoon holiday, so students who did not participate in the live stream will not have their grades affected. The reason I recorded this video is for students to watch the video by themselves. So later I will upload this video. And the next week is also a holiday, the National Day, and there will be no class and no live stream or recording, but assignment 2 will be announced on October 10th. And yesterday I updated the quiz results. You can check the scores to see whether the scores matches the score in your Zuvio app. And I also updated the accuracy of assignment 1. And many students have accuracy 0. And mostly accuracy 0 means the output format of your program is incorrect. And you must follow the instructions of assignment 1. Your output must be exactly the same as those in the provided examples, and this means you cannot add extra line breaks or omit any required strings. So I suggest you to review the code template, because the code template specifies the output format. Your output string must be exactly the same as the output string in the code template, and therefore I suggest you modify this template to finish the assignment 1 to avoid incorrect output format. And also I saw some students have accuracy 0 because they did not properly initialize variables, and I will I will use some examples to demonstrate this. About the output format, this is the code template, and some students add a line break after this. Some students add a line break here. For example, some students add a line break after the first string, and this will lead to incorrect output format because you add the additional line break. So do not add any line break by yourself. And I also see some students remove this line. If you remove this line, you omit some required strings by the assignment 1. So you cannot remove any required strings. And also I also see some students, they delete the strings, delete the space after the column. Some students delete space after the column, and this will also lead to incorrect output format. So I suggest you review the code template to finish assignment 1. And some students do not properly initialize their variable. For example, I saw some students write code like this. Some students declare a variable without initialization, and then he performs some arithmetics. And if you do not initialize a variable, then the value of this variable is unknown. So the value of variable 2 is unknown. And therefore, if you want to so you need to ensure that your variable is properly initialized. And in the previous week, we learned Boolean expressions and branching mechanism. This week we will learn for loop. We will learn loops. And when programming, we sometimes need to do some repetitive tasks. For example, you might want to print some message many times, or you want to generate a sequence of numbers, and then you need to use for loops. And there are 3 types of loops in C++: the while loop, and the do while loop, and the for loop. And I will introduce the syntax for the 3 types of loops. For the while loop, below is one example. While is the keyword in C++, and after the while keyword is a parenthesis, and inside the parenthesis is a Boolean expression. Then following the Boolean expression is the loop body. The loop body can be a single line or a compound statement. If the loop body is the compound statement, then you need to add a pair of braces. Let's take a look of the flowchart of the while loop. And we see that inside the parentheses is the Boolean expression. And when the program executes this while loop, the Boolean expression is first evaluated. If the Boolean expression is true, then the body statement will be executed. And then the program will proceed again to the Boolean expression. So the Boolean expression will be evaluated again. And if the value of Boolean expression is true, then the body statement will be carried out. And this kind of the loop will continues until the Boolean expression becomes false. So if the body statement changes the Boolean expression so that the Boolean expression becomes false, then this while loop will terminate. And we can use this example to illustrate how to use the while loop. And first, I declare a variable count, and its initial value is 0. And when the program executes this while loop, then this Boolean expression is evaluated. Because count is 0 and 0 is less than 3, so the Boolean expression returns true. Then because the Boolean expression is true, then the body statement will be executed. So the program will print hi, and then the value of count is added by 1, and this means count becomes 1. Then we go to this Boolean expression again. Now the value of count is 1, and 1 is less than 3. So the Boolean expression returns true, and then the body statement will be executed. So the program prints hi, and the value of count is added by 1. And now we know the value of count becomes 2. And again, this Boolean expression will evaluated again. Since count is 2 and 2 is less than 3, so the Boolean expression still returns true. And then the body statement will be executed, and the program prints hi, and the value of count is added by 1. And now the value of count becomes 3. And when the value of count is 3, then we see that this Boolean expression becomes 3 is less than 3. And this is not true, so the value of the Boolean expression returns false. And because the Boolean expression is false, the while loop terminates. And for this example, you can count how many times the body statement was executed. So for this statement, for this example, you can count how many times the loop body was executed, and also you can try to determine the value of count after the while loop. This is a simple exercise. So first, let's see how many times the loop body was executed. Should be 3 times, because if you trace the code yourself, you will find the loop body is executes 3 times, was executed 3 times. So we see that the message hi was printed 3 times. And you can also trace the value of count. For example, you can print the value of count. You can trace the value of count when inside the while loop, and we see that inside the while loop, the value of count is 1. for the first iteration. And for the second iteration, the value of count becomes 2. And for the where you print the value of count is also crucial, because I print the value of count after count is added by 1. So inside the while loop, for the first iteration, the value of count is 1, and for the second iteration, the value of count is 2, and for the third iteration, the value of count is 3. And when the value of count is 3, and this Boolean expression becomes false, and therefore the while loop terminates. And thus, after the while loop, the value of count is 3. So you can practice this example by yourself. You can modify the value of count, or you can modify the Boolean expression, or you can modify how the variable count is updated. The second loop syntax is the do while statement. Here we have another keyword do. Do is another keyword in C++. And after the keyword do is a pair of braces. This is the compound statement. We will put the body statement in after the do keyword, and after the body statement is the while keyword, and then we have a pair of parentheses. Inside the parentheses is the Boolean expression. And for the do while statement, the body statement always executed at least once, because when the program executes the do while statement, the compound statement will be executed at least once, and then the Boolean expression is evaluated. So no matter whether the Boolean expression is true or false, the body statement always will be executed at least once. So this is different from the while statement. The next one is the for loop. And before introducing the for loop, I will introduce the comma operator. When you want to evaluate a list of expressions, you will use the comma operator. For example, you want to declare multiple variables. You will use a comma. So suppose you want to declare 2 variables in a single line. Then we use a comma to separate the 2 expressions. So, and sometimes when we use the for loop, we will need to perform multiple expressions in a single line. So sometimes we will use the comma operator. And this slide shows the comma operator will generate a value, but this will have some side effects. So I don't suggest you use the return value generated by the comma operator, because this makes your code hard to understand. So I don't suggests you use this feature of the comma operator. Next is the for loop. The for loop is the most commonly used when you want to step through some integer variables in equal increments. And below is the syntax of the for loop. The syntax is more complex than the while loop. We see that for is the keyword, and after for is a parenthesis, and inside the parenthesis we have three parts. The first part is initial action, and the second part is the Boolean expression. The third part is the update action, and after the parenthesis is the body statement. So if you compare for to while, you will notice that inside the parenthesis of for, we have three parts. And we can take a look at the flow chart of the for loop. So when the program sees the for loop, the initial action will be executed, and this will be executed only once. So here is the initial action, and the initial action will be only executed once. And then the program proceeds to the Boolean expression. The Boolean expression will be evaluated many times. If the Boolean expression is true, then the program will go to the body statement. So if the Boolean expression is true, then the body statement will be executed. And after the body statement is executed, the program will execute the update action. And then the Boolean expression will be checked again. If the value of this Boolean expression is true, then the loop will continue. However, if the Boolean expression becomes false, then the for loop will terminate. So this is the flow chart of the for loop, and we will use one example to illustrate how to use the for loop. Here is one example. Suppose we want to compute the sum of a sequence from 1, 2 up to 10. So we want to compute the sum of 1, 2, 3 up to 10. Then we can write a simple for loop to do this. And first we need to generate the sequence. So the sequence begins from 1. So here here is the initial action. So we initialize the variable n to 1. And of course you need to declare the variable first. So here before the for loop we declare this variable first. Then we initialize its value in the initial action part of the for loop. You can also initialize the value of n when you declare this variable. So you can also initialize n in this line. And then the Boolean expression is n is less than or equal to 10, because the maximum value of n is 10. So here the Boolean expression is n is less than or equal to 10. And we also have the update action. The update action is plus n. Plus n means n is added by 1. So in each iteration, the value of n will be added by 1. So in this way, we can generate a sequence. We can generate a sequence 1, 2, 3 up to 10, and you can practice this by yourself. Now we have the for loop. We have the for loop, and we initialize the value of n in the initial action part, and then we need to write down the Boolean expression. And then we add in each iteration the value of n is added by 1. Then you can print the value of n in each iteration. And we see that we generate a sequence of numbers from 1, 2 up to 10. So you can use the for loop to generate a sequence of numbers. Then we need to compute the sum of this sequence. So we need another variable. So we declare another variable sum. And it is important to give the initial value. It is important to initialize its value. If you don't initialize this variable, then its value is undefined, and therefore the behavior of your program is also unknown. So it is important to initialize a variable. And here I do not initialize n because n is initialized inside the for loop. And in the for loop, because we need compound statements, so here I add a pair of parentheses if you have multiple statements. And I want to compute the sum of this sequence, so I perform sum plus equal to I perform sum plus n. So in each iteration, I will perform sum plus n, and I will assign this value to sum. So you can also print the value of sum. And let's see the program outputs. We see that in each iteration, when n is 1, the value of sum is 1. And when n is 2, the value of sum is 3, because sum is 1 plus 2. And when the value of when n is 3, the value of sum is 6, because the sum is 1 plus 2 plus 3. 1 plus 2 plus 3, so sum becomes 6. And so after the for loop, the value of sum is 55. And here is one question. Do you know the value of n after the for loop? So do you know the value of n? So you can try to compute the value of n after this for loop. And the value of n should be 11 after the for loop. Because if the value of n is 10, then the loop body will be executed. And then the value of n is added by 1. So after the for loop, the value of n should be 11. And you can verify this by running this program. So we see that this line is after the for loop. So after the for loop, the value of n is 11, and the value of sum is 55. And you can also use the while loop to perform to perform the same task. So you can also use the while loop to compute the sum of a sequence. And so the equivalent example is like this. First, we declare variable n, and its initial value is set to 1. And we use the while loop to generate a sequence from 1, 2, up to 10. And we also need to declare a variable sum to record the value of the sum of this sequence. So you can compare the syntax of while and the syntax of for. And you will find the syntax of for is more clear because you can see that you can see that the initial value of n and how n is updated, and the Boolean expression related to n are in a single line. So it is easy if you use the for loop. It is easy to track the value of n in this single line. But if you use the while loop, if you want to track the value of n, you need to see multiple lines. For example, if you use the while loop, you see that the initial value of n and the Boolean expression related to n are in different lines. So if you use the while loop, it is a bit difficult to trace the value of n. And it is very common to use the for loop to generate a sequence of numbers. And later, when we learn array, we need to use the index variable. And at that time, we will use the for loop to generate a sequence of index, and in order to use array. The next slide is about repeat the loop n times. So for example, we want to repeat the loop body 3 times, and you have 2 ways to do this. You can initialize the count to 1, and the Boolean expression is count is less than or equal to 3. So this is the first way to do this. Or the second way, you can initialize the value of count to 0. If you use this style, then the Boolean expression becomes count is less than 3. So both can be repeat the loop body 3 times. You can choose which way you want to use. And we humans are more familiar with the first style because we all often count. When we perform counting, we usually begins from 1. So the first way is we are more familiar with the first weight. However, for C++, the second way is more common, because when we introduce array, we will use the array index, and the array index always begins from 0. So when we introduce array, we always use the second style, because the array index begins from 0. And this variable is also referred to as the loop control variable, and this loop control variable need not to be used in the body statement. So you see that the body statement do not use the loop control variable. The next slide is about pitfall when we use the for loop or the while loop. And from this example, we see that if you place a semicolon after the parentheses, and the syntax is okay, but the program outputs might be different from your intention. So let's try to execute this sample. So first I remove the semicolon because usually we don't put a semicolon after the parentheses, and we see that the for loop will print hello 10 times because the loop will repeated printing the hello 10 times. So let's run this program. And we see that the hello was printed 10 times because count begins from 1 and up to 10. And when we add a semicolon after the for loop, let's see what happened. And first, let's compile this program. We see that the program output is different from the previous one. Now the program only print hello for one time. This is because when you put a semicolon here, then the loop body is empty. So when you put a semicolon here, this means the for loop will the body statement is the null statement or empty, because between the parentheses and the semicolon is nothing. So the body statement is the null statement. This means you performs nothing. So we execute this for loop for 10 times, but the loop body performs nothing. And after the for loop, then the program will execute this, will print hello. So this statement is not inside the for loop. So this statement is actually outside the for loop. So usually we do not add a semicolon after the parentheses of 4. But if you accidentally add a semicolon after the parentheses, the syntax is legal, but the program outputs might be different from what we expect. And also, the next example is also you add a semicolon after the while loop. Let's see this example. So here we need to declare the variable response. And first I remove this semicolon, and then we can run this program. So the program shows enter some value, then I enter So so cout prints enter some value, and the cin will read user input. So here I enter, for example, I enter 2, and then I press enter. Then because I enter 2, the value of response is not 0, so the Boolean expression returns true. So the loop body will be executed again. So cout prints enter some value, and then cin will wait for the user to input some value. So next I input, for example, -1. After I enter -1, I press enter. Then the Boolean expression will be evaluated. This time response is -1, and -1 is not equal to 0. So Boolean expression returns false. And then the loop body is executed again. So the loop body prints some message and wait for the user to enter some value. And this time I enter 0. When I enter 0, the while loop terminates, because if response is 0, then the Boolean expression generates false, and when the Boolean expression is false, then the while loop will terminate. And when the while loop terminates, the program execute returns to 0. So we see that. But when you add a semicolon after the parentheses of the while loop, you will notice that this will introduce the now statement. So here, this single line contains the loop body. The loop body is the now statement, and because the loop body is the now statement, we have no chance to modify the value of response. The value of response is always 1. So this will create an infinite loop. So this means the while loop will run forever, because we have no chance. You have no chance to modify the value of response. So the program will stuck at this line. We have no chance to go to the statements after the while loop. So you see that if you run this program, you cannot see any message, because the program is the program stucks at the while loop. And if you want to terminate the program execution, you need to type Ctrl+C. You can type Ctrl+C to interrupt the execution of this program. So if you add a semicolon after the parentheses of the for loop, you will create an infinite loop. And sometimes we need an infinite loop. Sometimes, for example, for some embedded systems, we want to run a loop for forever, because we want to listen into some message. Maybe we want to wait for the user to input some message. So we need to write a for loop to listen in to the user. And this time you need an infinite loop. The next slide introduce two statements related to the for loop or while loop. So in these statements introduce the break and the continue statements. Break and continue are two keywords in C++. This means you cannot use break and continue as variable names. Here is one example related to the break statement. The loop control variable is iter, and its initial value is 1. And the update action is plus plus iter, which means iter is added by 1. And the Boolean expression is iter is less than or equal to 10. And the loop body is a compound statement because it is inside a pair of braces. And we see that the loop body contains the if statement. This if statement determines whether iter is equal to 3. If this is true, then the break statement will be executed. When the break statement is executed, the for loop will terminate immediately. So the break statement will immediately terminates the loop. So if the program executes the break statement, then this for loop terminates, and the remaining statement will not be carried out. So we can you can use this example to trace the value of the loop control variable. And so for this example, you can try to answer what is the value of iter after this for loop. So you can try to answer this question: what is the value of iter after this for loop? The second question is how many times the hello message will be printed. So you can try to answer this question to see whether you understand the flow control of the for loop and the break statement and the usage of the break statement. So I will show how to. I will use this example to demonstrate how to use the break statement with the for loop. And usually we will perform indentation to increase the readability. But this indentation will not affect the program outputs. The indentation means the leading spaces in each statement. So first, I declare the iter variable. This is the loop control variable, and I do not initialize it because this variable will be initialized in the initial action of the for loop. So here I did not perform initialization, and then we can trace the value of iter. So we see that for the first iteration, the value of iter is 1, and the 1 is not equal to 3, so break will not be executed. So the first expression will print hello, and then iter is added by 1, so iter becomes 2, and iter becomes 2, then this Boolean expression will be evaluated. 2 is less than or equal to 10, so the Boolean expression returns true. Then we will go to the loop body. Iter becomes 2. 2 is not equal to 3, so break will not be executed, and the loop body will print hello. And then the value of iter is added by 1, so iter becomes 3, and the 3 is less than or equal to 10, so the the loop body will be executed because the Boolean expression is true. Then we go to this line. When iter is 3, then the if statement will be executed because 3 is equal to 3, and the break statement will be executed. And then this for loop terminates. So we can try to print the value of n inside in each iteration. So here I print the value of n, the value of iter in each iteration. So for this example, we see that the for loop executed, the loop body was executed 2 times. The first time prints hello, and the value of iter is 1. The second time prints hello, and the second iteration prints hello, and the value of iter is 2. And when iter is 3, the for loop terminates, and therefore this line will not be executed. And after the for loop, we see that the value of iter is 3. So the last line prints the value of iter. And you can also try to move. You can exchange the order of the statements. For example, I change the order of the 2 statements, and the program outputs will be different. You see that if I change the order of the if statement and the cout statement, the program has different outputs. Hello was printed 3 times, and this is because when iter is 3, cout will be executed, and then go to the if statement. So if you exchange if you exchange the cout statement and the if statement, the program output will be different. And this is the usage of the for loop and the break statement. And I think we can take a break for about 7 minutes. So the class will start at 10:10. So let's take a break for 7 minutes. Hello all, and let's continue our class. If you have any question, you can send a message, and if I see the question, I will respond as soon as I see it. And we have learned the for for loop with the break statement. And next, let's see the continue statement. If if we exchange the break statement with the continue statement, and the program execution will be changed. The continue statement means to merely ends one loop iteration to merely ends one loop iteration, and the next iteration continues the loop. So the continue statement will only skip one iteration. However, the break statement will terminate the loop. So this is the difference between the break statement and the continue statement. The continue statement only skip one iteration. So let's see the example. So for this example, if we change the break statement to continue. So let's see the program outputs. So we see that the iteration is hello. The program outputs is hello one, hello. Sorry. So here I exchange the order of the two statements. So here we see that the first iteration prints hello 1. The second iteration prints hello 2. But the third iteration is skipped, because if iter is 3, then the continue statement will skip the remaining statements inside the for loop. So the statements after the continue statements will be skipped. So we see that we do not see hello 3 because hello 3 is skipped. And after the continue statement, the for loop continues. So the next iteration is hello 4 and hello 5 until hello 10. And when iter is 11, when iter is 11, this Boolean expression becomes false. So after the for loop, the value of iter is 11. And here is one remark about where to declare the variable. You can also declare the variable in the initial action. So you can initialize the variable here. You can declare the variable in the initial action part. But if you declare the variable in this part, in the initial action part, you cannot access this variable outside the while loop. So if you you do this, you cannot access this variable outside the for loop because the scope is only within the for loop. So if you try to compile this program, we see the output error message. Iter was declared in this scope because the scope is only within the scope of iter is only within the for loop. If you declare this variable in the initial action part, so you cannot access iter outside the for loop. If you declare the variable in the initial action part. So if you want to access the variable outside the while loop, you need to declare this variable outside the for loop. The next slide introduce nested for loops. You can use for loop inside the for loop. So here is one example. And if you want to use break or continue in the innermost loop statement, and this will the break or continue statement will only affect one for loop. So if you use break or continue, break will break only one for loop. Break will not break the two for loops. Here I will use some example to demonstrate how to use the nested loops. Now suppose we want to print, for example, we want to print 2 times 2, 2 times 4 is 8. 2 times 8 is 16. So now suppose we want to print this message. So I want to print 3 times 2 is 6. 3 times 4 is 12. 3 times 8 is 24. So suppose I want to use for loop to print these outputs. So let's see how you can use for loop to do this. Then we need loop control variable. So for example, I have I. So I have I, and begins from 2. So here I represent this number. I begins from 2. And we also have a multiplier 2. So I use this m to represent this number. So I use m to represent this number, and I use I to represent the second number, and this number begins from 2, and is added by it's multiplied by 2. So the update action is I times by 2. And the Boolean expression is I is less than or equal to 8. So the initial action is I is 2, and in each iteration I is multiplied by 2. So 2 times 2 is 4, and 4 times 2 is 8. and we can try to print the value of I to ensure that uh, our expression is correct. So we can try to print the value of I. So you see that the value of I is 2, 4, 8, and then we need to form this string. So we need to form this string, and this string is we need to print the value of m, and we also need to print x times. So here we print m times I. So let's see the program outputs. So here we print 2 times 2 times 2, 2 times 4, 2 times 8, and we need to show the multiplication results. So then we need to show the equal sign, and then we need to show the multiplication result. So here we see that we print 2 times 2 equals 4, 2 times 4 equals 8, 2 times 8 equals 16. And we can, if you want to put the 3 equality in a single line, then we need to remove the new line character, and here we add a comma after and a space. So in this way you can print the 3 equality in a single line. So we see that we print the 3 equality in a single line, and then we need to print the second line. The second line, you need to modify the value of m to 3. So if you can try to modify the value of m, then we see that the 3 equality becomes 3 times 2 is 6, 3 times 4 is 12, and 3 times 8 is 24. But we need to print the 2 lines. We need to print the 2 lines, so we can use nested for loop. So now we can use the nested for loop. We use int m is 2, and the m is less than and equal to 3. In each iteration, m is added by 1. So we also need a pair of braces because we use compound statements. The compound statements is the for loop statement, and the second statement is the cout statement. So this is a compound statement because we have more than one statement. So you need to add a pair of braces. And let's see the program output. And you see that this is the first line, this is the second line. So the first line is the execution of the first iteration. The first iteration will print 2 times 2 up to 2 times 8. And the second iteration will print 3 times 2 up to 3 times 8. Of course, you can have more iterations. So in this way, you can learn how to use the nested for loops. Here, this slide shows another example, and you can try to run this program to practice how to use the nested for loop. we can, for example, here we can add a break statement. We can So here I add a break statement. You notice the position of this statement. If you add the break statement here, this statement will break the outer for loop. So this break is independent of the inner for loop. So if you put break here, this break will break the outer for loop. So you see that 5 times 2 and 5 times 4 is not executed. And if you put the break statement inside the inner for loop, for example, I put So here I put this break statement inside the inner for loop, and let's see what happened. We see that this break only breaks the inner for loop. So when m is 4, and when m is 4, and the for loop is executed, and we see that CR will print 4 times I. So we see that 4 times 2 equals 8, and then this statement is executed. So the inner for loop breaks immediately, and we do not see 4 times 3, 4 times 8. And this break only breaks the inner for loop, and the outer for loop is not affected, and therefore the outer for loop continues. So you see that the outer for loop continues. And we have finished the introduction of the for loops. And the fourth part is about file input. We have learned we can use cin or cout to read user inputs, and you can also read inputs from some file in the disk. For example, you have a text file. You want to read inputs from the text file, and if you want to do this, you can use the you can use the data type if string. You can use the input file string. This is a data type defined in the IOString library, and you need to associate you need to use this data type to declare a variable, and associate this variable with the file name of the file name of the text file in the disk. And you can use this example to read strings from the player text player.txt. And I will skip this part. If you are interested, you can take a look at the textbook. So we have finished this chapter. And next, in this week, we have no quiz, but I will show the questions of the quiz so that you can practice yourself. The first question is you need to determine the values, the Boolean value, the values of result 1 and result 2 after the three statements. And I will pause for 1 minute, and after 1 minute I will show the answer. So you can try to compute the value of result 1 and result 2. For this question, the answer is the false one, and result 1 is false, and the result 2 is true. Let's compute the value of result 1. We see that x is larger than y because x is 3, y is 2. But z is not larger than y because z is 1, y is 2. So the first Boolean expression is true. The second Boolean expression is false. And if you perform the AND logical operator, since one input is false, so result 1 is false. And the next one is the OR logical operator. And because one input is true, so the OR logical operator will return true. So result 2 is true. Next, let's see the second question. For the second question, you need to determine the value of y after the above statements. And I will also pause for 1 minute. The answer of this question is the second one, y equals 4. Let's execute the statements. The value of x is 9, and if we perform the modulo operator, the value is 1. So 1 is not equal to 0. So the value of this Boolean expression is false, and therefore the condition is false. So condition is false, then the else part will be executed. So y will be added by 1. So y is 3, and 3 plus 1 is 4. And therefore, the answer of this question is y equals 4. And next, let's see the third question. Suppose the value of the variable bonus is 10. And after executing the above statements, you need to decide the value of bonus. And I will pause for 1 minute before showing the answer. The answer of this question is, I think, so the answer of this question is 30. Let's execute the statements. We see that the value of day is 11. And the following if statement, we need to execute the following if statement. So day is not less than 10. And the program proceeds to the else if statement. And for this one, you notice that here is the assignment operator. Here is the assignment expression. This is not comparison. If here is comparison, you use double equality. However, here is the assignment operator. This is legal, although we seldom do this. So here, if you assign 24 to day, this will return 24. And 24 is not 0, so the Boolean expression is true. And because the Boolean expression is true, so bonus is added by 20. So 10 is added by 10. So the value of bonus becomes 30. You can try to run this program. So let's run this program. So we see that the value of bonus is 30. This is usually due to typo. We seldom do this. We seldom do assignment inside the inside the parentheses. So we usually perform comparison, and if you perform comparison, the result should be 10 plus equal to 30. So the result should be 40. And next I will go to the next chapter, and we have finished flow of control. Next I will go to arrays, introduce arrays. And so let's open the slides of this chapter. And this chapter has 4 parts. The first part is the introduction to arrays. The remaining parts will use function. So first I will introduce the introduction. So first I will introduce arrays, and then I will go to the next chapter, function basics. And after we finish function basics, we will return to the remaining parts. We will returning to arrays, how to use array with functions. And when programming, we usually want to use a collection of data. So for example, you might want to declare score 0, score 1, score 2, score 3 to record the score of some student. So for example, you have 5 students. You might want to declare 5 variables to represent the score of each student. But this is very tedious, because if you have 100 students, you need to declare 100 variables, which is very difficult. And therefore we have another syntax. We have array. Array allows you to declare many variables very quickly. So for example, I want to declare 5 variables. You can use this syntax. So after the this is the array name. This is score is the array name, and after the array name is a bracket, and inside the bracket is the array size. So 5 is the array size. Array size means the number of elements in this array. So if you execute this statement, this statement will declare an array, and this array has 5 integers, has 5 elements, and each element is an integer. So array is a in C++. Array is a collection of data of the same data type. So if you want a collection of data of different data type, and this is not possible for C++. If you want to use built-in data types, the built-in data types in C++ requires the same data type. So you can declare an array of integer variables, or an array of float variables, or an array of character variables. And if we want to access the array elements, you can use syntax like this one. So for example, we want to access the array element at index 3, you can use score and bracket. And inside the bracket is the array index. This is not the array size, this is array index. And the following figure shows how you declare an array. So for example, you want to you declare an array. Its array name is ARR. This name is can be you can choose any array name you want, as long as it follows the C++ naming principle. And this array has 6 elements, and each element is an integer. And the index, we also have the index variable. If you want to access this array, you need to use index, and the index begins from 0. So if we have 6 elements, then the index begins from 0, 1, 2 up to 5. And if you want to access the value at index 3, this means suppose you want to assign 10 to this array element, then this means we assign 10 to the array element at index 3. And it is important to know that if you only declare this array and you don't perform any initialization, then the initial value of these array elements are unknown. So this is similar to the variable declaration. If you declare a variable without initialization, then its value is unknown. This is very important in C++. So similarly, if you do not initialize an array, then the initial value of each element in this array is also unknown. And later I will introduce how to initialize an array. So for example, you use array bracket 0. This means you are accessing the array element at index 0, which is the first element. And if you use array bracket 5, this means you are accessing the array element at index 5. And this is the last element in this array. And below are some common pitfalls when using array. I will show some typical errors when using array. Now suppose you want to declare an array variable. So I declare a array variable. And we should know that we should distinguish the meaning of the number inside the brackets. So when you declare an array, the number inside the bracket means array size. So when you declare so for declaration, the number inside So for declaration, the number inside the bracket denotes array size. However, if you are context. For example, in this line, you are accessing array elements, and in this line, the number inside bracket has a different meaning. So in this context, the number inside the bracket so this number means array index. So you see that in different contexts, the number inside the bracket has different meaning. So you need to distinguish from this. And it is important to pay attention that you need to ensure the index is within the legal range. The legal range is from 0 up to size -1. So if you declare an array of size 5, then its index is from 0 up to 4. So one typical error is like this. So I will show one typical error is you try to access array element at index 5. So this calls index out of range, because 5 is outside the 5 is outside the legal range. The legal range is from 0 up to 4. And if you try to if you try to run this program, you do not see any error message, but actually, although we do not see some error message, but here is one error, and this error might not affect the program execution. So you might not. So when index out of range occurs, you might not notice. However, because this behavior is undefined, so sometimes error does not occur, but sometimes your program might crash, because this can lead to undefined behavior. So you need to make sure that the index is always within the legal range. So this is a very common error for beginners to use array. And we usually use array as storage. You can use array to store the scores of many students, and you can use index to access the score of each student. And later we will have more examples demonstrate how to use array. So here are two important points. Uh, the first point is you understand the meaning of the number inside the brackets. So we have two different scenarios. For the first scenario, if for declaration, the number inside the bracket means array size, and when you are accessing array elements, the number inside the bracket denotes array index. And the second point is to understand that you need to ensure the index is within the legal range. The legal range is so the legal index range is from 0 up to size -1. So array size -1, and here array size is 5. So 5 minus 1 is 4. If your index is outside the legal range, then this will lead to index of outer range. And the index outer range sometimes leads to the crash of your program, or sometimes your program shows no error. So it is hard to detect whether this type of error occurs. I saw some students write code like this when for assignment 1. I saw some students want to use array, and he declare array like this. He declare array. So he declare array of 5 elements, and he tried to access array 1. Array 2. So for assignment 1, I saw some students write source code like this. He declared an array of 5 elements, and then he tried to access array elements in this way. And here he commit one mistake, because he thought array index begins from 1. So he access array like this. However, we know here index 5 is outside the legal range. So here this assignment can actually lead to unknown undefined behavior. This can lead your program to output unexpected results. So this is one common mistake. If you do not pay attention, it is easy to have a mistake like this. So the correct way is to ensure the index begins from 0. The index is not begins from 1. another important issue is that I will show another important issue about how to use this array. You must know that the array is static. Static means after you declare this array, its memory size is fixed. You cannot adjust its array size. So this means I saw some students write write code like this. He declare a variable. Then he used this variable as the array size. Then later he changes. The variable number. For example, he changed number to 5. So here is one example. After you change the number to 5, will the size of this array be changed? We see that the array size is determined by the value of number. So we know the array size is 3 in this line. The array size is 3. And later we change the value of this number to 5. And will this line change the array size to 5? This is very important. This is very important. So you need to decide. You need to understand the array size. And if you want to check the array size, you can use the size of operator. So here I print the array size. So this will return the number of bytes in this array, and because this array has 3 elements, and each element is an integer, and the integer data type has 4 bytes. So 4 times 3 is 12. So the size, so this array has 12 bytes. So this array has 12 bytes, and you can divide the size of integer to obtain the array size. So here because we know each element is an integer, so here I divide the size of integer, and we can obtain the array size. The array size should be 3. Or you can also write here. You can also use array. You can also use the first element, because the first element is an integer, and one integer has 4 bytes. So we can obtain the array size in this way. And next we modify the value of this number. We modify the value of num, and let's see whether the size of this array will be modified. So let's run this program. You see that even though you modify the value of num, the size of this array is not changed. This is because this array is known as static array. So this is static array. Static means after declaration, its size is not changed. You cannot change the size of a static array. If you want to change the size of an array, you need to use a dynamic array. And later we will introduce dynamic array. For dynamic array, you need to allocate memory by yourself. So if we declare array in this way, this means this is static declaration. This means we cannot adjust the array size. The array size is always fixed to 3. So it is important to know this principle. It is important to know this declaration is static declaration, because some students so we shouldn't write code like this, because this kind of code is confusion, because you might, because number is a variable, you might think the array size can be adjusted. In fact, we cannot adjust the size of a static array. So this is not clean code. This kind of code is confusion. Leads to confusion. And a better way to write this is to use the naming constant. So you can use a better style is this. You use a naming constant, and usually we will use uppercase. We will. This is a convention, naming convention. We usually use this. So, and if you use naming constant, so here I use naming constant, and you are not allowed to modify the value of a constant. So here I cannot modify the value of a naming constant. So you see that here is the error message. We cannot modify a read-only variable num due to this const modifier. So when we declare an array, when we perform static declaration, its array size is fixed. We have no way to change the size of this array. I think we can take a break for 10 minutes. So let's take a break for 10 minutes. The class will resume at 11:20. Hello, hello all, and we will resume the class. Next, I will introduce how to use for loop with arrays. When we want to access array elements, we usually use a for loop. Uh, so here is one example. Now suppose here, if you want to perform array initialization, you need to use a pair of braces, and inside the braces is inside the braces is the initial value. So here I initialize the 5 elements. Now suppose we want to print the value of each element, and you can use the for loop. And now suppose we want to access each element in this array. You need to create the index from 0, then up to minus the index is less than 5, because the largest value of the index is size -1, and then we can print the value of each element. So we see that the value, the elements inside this array are 5, 9, 8, 5, 0. So you can use the for loop to access array elements. And I also introduce a common style is to use naming constants. Here the array size is 5. So later, if you want to change the array size, you need to manually modify 2 lines. A better convention is to use naming constants. So a better style is to define a naming constant. So this is a better style, because I define a naming constant. And later, if I want to change the array size, I only need to modify the value of this constant. So it is a good habit to use the naming constant. And now suppose we want to, for example, we want to find the largest value inside this array. And this is one common operation. You can think about how to find the largest element inside this array. In the slides, here is one solution. This piece of code shows how to find the largest score, and you can try to do this by yourself. And this is a clever approach, because you don't need to sort the entire array in order to find the largest score. So this is a clever approach. Suppose now we want to find the largest element. So here, so for example, the largest element. So I give some initial value to this variable, and here we want to find the largest element. So here we need to use compound statements, because we have more than one statement. So I add a pair of braces, and we need to compare the array element. We need to compare the array element to this largest variable. So if the array element is greater than the largest, if the array element is larger than the largest variable, then we change the value of this largest variable. So we modify the value of largest to scores at index I. So inside the for loop, we have only one statement, and this statement compares the array element at the index I to the largest variable. And if the array element at the index I is greater than the largest variable, then we assign the value of the score at index I to largest. Then let's run this program to see the output. And we see that after the for loop, the value of largest is 9. 9 is the largest value in this array. Or you can try to modify some number, some array elements. You see that if I modify the array elements to 10, then the largest element is 10. This piece of source code has some problem. The problem is that we need to determine the initial value of largest. If you choose a larger, for example, if you choose 11, if you choose too large, if the initial value of largest is too large, then you will not able to find the largest element, because the largest will be 11. So it is important to choose the proper initial value of this largest. What is worse, if you do not initialize this value, this is worse, even worse, because the behavior is undefined. Sometimes it can find the largest one, but sometimes outputs the wrong value. So this behavior is undefined. Its value is undefined. So a clever way is to let the initial value be the first element. So a clever way is to let the initial value to be the first element in the array, and then we can modify. We can also modify the initial value of I, because we don't need to begin from 1. So if the initial value is indexed at 0, then we can modify I to begins from 1. So we see that we can also find the largest value of this array. And this is the approach presented in the slides. So this is one common operation associated with array. And similarly, you can use a for loop to find the smallest element in this array. One major array pitfall is the index out of range error, and this can lead to unpredictable results, and the compiler will not detect such errors. So index out of range is hard to find and hard to detect, because your program might show no error messages, so you don't recognize your program has index out of range. So this is one common pitfall. You declare an array whose size range is 12, and you let the index range you let the index to be 12. The index 12 is outside the legal range, because the largest legal index is 11, and the compiler shows no warning, and your program might be okay, and your program might shows no error message. So it is hard to detect index out of range. It is programmer's responsibility to check the index range. And I also introduced use naming constants. Here is the naming constants. So if you need to declare an array, and we usually use naming constants, because this can improves readability and maintainability. It makes your program easy to maintain. And later, if you want to change the array size, you only need to modify the definition of the naming constants. And if you want to access the last element, you need to the last index, and the last index is array size -1. So it is convenient to use naming constants. The next slide is about another syntax for the for loop. This is called the range-based for loop. This syntax is introduced in C++ 2011, and the syntax is like this. I will skip this one. If you are interested in range-based for loop, you can take a look at the textbook, or you can search range-based for loops by yourself. Next I will discuss about readability. the readability of your source code. Some students write code like this. Now suppose I declare an array with 5 elements, and we want to compute the average value. We want to compute the average value of the 5 scores. And I often saw students write source code like this. And let's see the output of this program. Also, here I should use float because we want to compute the average. So here I should use float. Oh, sorry. Float. I should use S should be float. Oh, here I also we need a float division. So here I add a floating point, a decimal point. We see that the average value of the array elements is 3. So the piece of source code can output the correct average value. However, the readability of this source code is very low. This kind of source code is difficult to understand. Difficult to understand its intention. A better way is to use better naming. So I will show you a better style. So below are better style. You give meaningful array name. So for example, the array name means seats per game. We have 5 games, and the array element is the number of assists in each game. And we want to compute average viewers, and average viewers so average viewers is the assists per game divided by matches per season. So let's see the program outputs. Here match per season, and here we need floating point division. So here we need floating point division. so I run this program again. So this is 3, and I think so. I think I need to modify this example, and also we can print its value to see what happened. So we can print its value to see what happened. So we see its value is 0 inside in each iteration. And why this is 0? Because 1 divided by, oh, so I need to change its data type. So we see that I need to change its data type, otherwise because this is a floating point and this is an integer, and if you assign floating point to an integer, some precision is lost. So if you assign 0.6 to an integer, then 0.6 will be discarded and 0 is assigned to this integer. So here I need to change the data type. So we see that after the for loop, the value of average viewer is also 3. And if you compare below with the above, you will find below is more readable because the array name or the variable name and provides meaningful information. And also here you use the naming constants, and naming constants allows you to maintain your code more easily. For example, here I want to change it to 10 persons, and you only need to modify this line. However, if you use the above, you need to modify the array size in many places. Also, below is a better style. This style is called clean code. Clean code can improve the readability of your source code and makes you easy to maintain your source code. I think today's class is over, and we can stop here. Thank you for joining this live session. And later I will upload this video to the course website. So I will I will finish this live session.